Hi, I'm Ursula Sodick with Autodesk Plant Solutions. In this video, we will introduce you to the basic tools involved in designing a PID with AutoCAD PID. First, we'll add components and schematic lines to our drawing. Then we'll validate the drawing and correct validation errors. We'll add inline components and instruments. And finally, we'll complete a few editing operations and tag and annotate one of the components. First, I'm going to add a pump to my drawing by clicking it on the tool palette. Then I'll click an open area to specify a location for the pump. We'll add tagging information and annotations later, so I'll click Cancel on the Assign Tag dialog box. Next, we'll add a tank to our drawing. I go to the Equipment tool palette, and under Storage Tanks, I'll click Dome Roof Tank. Then I'll click an open area in the drawing and place the tank. I'm prompted for a scale factor, and I'll just accept the default scale. And again, I'll click Cancel to skip the step of assigning tag, which we will do later. Now I'll connect these components with a pipeline. Back in the tool palette, I go to the Lines tab and click Primary Line Segment. In the drawing area, I'll click the top nozzle of the pump to place a primary line and click to the left of the tank to set a second point of the pipeline. A nozzle is automatically created when the line is connected. As you can see, a pipeline is displayed with arrows that indicate the direction of flow. Next, we'll do a validation. We'll start with configuring the validation, then validate the drawing, and then fix a common error. To view validation settings, I go to the Home tag and click Validate Config. The PID Objects node is already expanded, and all of the checkboxes are checked, which is what we want. I'll expand the base AutoCAD Objects node and clear each checkbox. We can also view descriptions of the arrow types by clicking on each one and referring to the text in the lower portion of the dialog box. Now we'll click OK. Now we'll validate this drawing. Back in the ribbon, we'll click Run Validation. We get a Validation Progress dialog box. When the validation is complete, the validation summary window displays the results. We have an unconnected component error. I'll click the arrow node. In the drawing, the horizontal centrifugal pump is highlighted because its left nozzle is not connected to a line. This is fine, we just haven't gotten to this other side of the pump yet. We'll go ahead and fix that now. In the Equipment tab of the tool palette, under Storage Tank, I'm going to put another dome roof storage tank in to the left of the pump. I'll accept the default scale and skip the step of assigning a tag. Now I'll connect the tank to the left nozzle of the pump with a schematic line. To make sure the flow direction is from the tank to the pump, I start the schematic line at the tank and connect it to the pump. Notice how flow arrowheads indicating direction show up automatically on the schematic line. Now, just to show you what a flow direction error looks like in the validation dialog, I'm going to erase the schematic line and redraw it, this time starting at the pump and ending it at the tank. So again, picking schematic line from the tool palette, drawing from the pump to the tank. Now I'll click to run validation again after I save this drawing. And when the validation's finished running, we get one error, which is a flow direction conflict. Flow direction conflict, an error with our untagged pump. Okay, we can reverse the line to fix the error. To reverse flow, you right-click on the line and pick the menu option under Schematic Line Edit of Reverse Flow. Now save the drawing again, run validation again, and when the validation is complete, we should get a message saying there are no validation errors. Great. I'll press OK to clear this dialog. Now we're going to add some inline components, starting with valves. I'm going to zoom in around the discharge line of the pump and change our tool palette to the Valves tab. And then first we're going to place a gate valve. So we'll click the gate valve symbol and then click the horizontal line to place the valve. Next, we'll add a control valve to our drawing, which we can get from either this Valves tab or from the Instruments tab. We'll click the control valve on the tool palette. The very first time you pick a control valve, it'll ask you to set default body type and actuator type for this valve. I'm going to pick gate valve as a body and diaphragm actuator for my top works, and press OK. Now I can place my control valve in the line. I'll click the horizontal line to place the control valve, and when prompted, I'll select an annotation position for the instrument bubble. I'll click where I want this bubble to place. And again, I'll skip assigning a tag. Now I'll add a reducer to one of our lines. In the tool palette, I'll click the Fittings tab, and under Pipe Fittings, I'll click the eccentric reducer. Next, I'll click a line in the drawing to place a reducer on the line. Now that we have a few components, let's explore some of the typical editing tasks you perform while designing a PID. First, let's move the tank. I'll click anywhere on the border of the top tank to select it. On the lower left corner of the selected tank, I click the grip to drag the tank to the left along a horizontal line. Clicking places the tank in the new position. Note that the gate valve adjusted to fit the shortened horizontal line. I'll move it again to demonstrate how the valves adjust. Next, I'll move the gate valve. Before I do that, I'm going to click the off the Object Snap button to turn off snap behavior. I do this to keep the gate valve from jumping to the end of one of the lines when I move it. Now I click the gate valve, pick its grip, and drag it from the horizontal line to the vertical line. We can see that the valve has flipped to a line with the vertical line. And also, the horizontal line has healed where the valve used to be. Next, I'm going to change this gate valve to a ball valve. Instead of erasing this valve and picking a ball valve from the tool palette, I can simply substitute it in place. Click the valve, I click the substitution grip, and you'll see a small palette of all the available valves in this project. I'm going to pick my ball valve, and in place, my gate valve will change to a ball valve. Now I'm going to move the top horizontal line. First, I'll select the line, which will highlight the whole line, including any components on it. And then I'll click the up-down arrow grip on the middle of this line. Notice when I move the line, the control valve and instrument bubble move the line, but the tank does not. Next, we're going to explore how to tag and annotate. The first thing I'm going to tag is the horizontal centrifugal pump that we placed earlier. So we'll go ahead and zoom in on this pump so that when we tag it and place an annotation, it'll be easier to place the text close to the pump. I'm going to need to deselect the line here. I'm going to right click and deselect all, or I could have hit escape. And now I'm going to pick the Assign Tag button from the ribbon and click on my pump. This will bring up again the Assign Tag dialog. This time we're going to go ahead and fill it out. Depending how your administrator has set up your project, you may be prompted to tag with more or less subparts. By default, the equipment is tagged with a type and a number. There's a button for existing tag numbers you can click, which will expand a dialog showing all the existing pumps, in this case, already in the project. This can help you pick a unique number to assign to an asset. In this case, we're going to enter 110 in our dialog box. We're going to click Place Annotation after tagging and hit the Assign button. We now get a drag line from our pump, and we can place the annotation anywhere on the page. And there you have it, a quick introduction to basic design tasks in AutoCAD PID. Thanks for watching.